let me first explain to you what factoring is, okay? Factoring, now we have been foiling, right? Or you have foiled before. I told you I don't like the word foil, but whatever. Say I have x plus 3 times 2x minus 1. And we could multiply that out, right, to get what we call a trinomial with 3 pieces. Right now this is 2 binomials, 2 pieces. And we could multiply it out. What's x times 2x?
2x squared.
What is x times negative 1?
Negative x.
What is 3 times 2x?
6x.
3 times negative 1. And I clean it up to get 2x squared plus 5x minus 3. Now I show you this because it's very important that I show you in steps as we multiplied from here to get to this point. So factoring takes the trinomial, takes us to this step, and ends us up back here with 2 things being multiplied together. Okay, so we're backwards foiling basically is what we're doing. All right? Now, here's the key, and I must go over this for just a second. This is probably, I think you probably first learned this maybe in 7th, 6th grade, maybe. Maybe not quite. I don't know. Not this, but what I'm fixing to tell you. What does it mean to be a greatest common
Multiple
factor?
We made a cake in Algebra 1.
And that has to do with the greatest common factor because...
I don't know. That's what
We didn't make a cake in our class.
Yes. All right. So, look. Yeah, different than least common multiple. Okay, least common factor. When you think about factoring, we're thinking about backwards multiplying. We're thinking about dividing. Okay, so greatest common factor is the greatest thing that goes into that number. Greatest value you can divide by evenly. No remainder, right? Remainders are bleh. So, very basic. If I had the numbers 15 and 21, what would and I'm going to call them GCFs from here on out because that's just... The greatest common factor here would be 3. Why? It's the biggest thing that goes into both of them with no remainder. What if this were 15x squared and 21x? What then would the GCF be? 3x, because I can also divide both of them by an x. Does that make sense to everyone?
Yeah.
Okay. Y'all sure?
No.
Okay. The very most basic form of factoring is taking a GCF out of a polynomial. Okay, so for example,
How do I turn this pen on?
You press the button.
It's not working.
let's say I have 6x squared plus 12x minus 3. Your very first step in factoring, and in fact it is factoring, it's just basic factoring. Anytime you take anything out, you are factoring. Do you have a GCF here?
Yes.
A 3, right? Can you take that out and rewrite the problem taking it out?
Show me how though.
Okay. I'm going to put the GCF on the outside. And what's left when I take it out? So think backwards distributing. 2x squared. We always hold the place with the 1 if we take everything away. Okay? Because 3 divided by 3 would be 1. If you distributed through, do you get back what you started with?
Yeah.
Okay, so I did it right. How about this one?
Binomial.
Well, I'm going to get to that. Right now I'm just showing you factoring out of GCF first because that's our first step in factoring. Then we're going to get to the binomial part. What if I had 8x to the 4th minus, for right now, we haven't got to the good factoring part. Does that have a GCF?
No. Yes.
X squared. They both have two x's they can get rid of, right?
Yeah.
How would I factor that out? What would it look like?
Put x squared times 8x to the second
Minus 3. Your GCF, remember, come on, goes on the outside.
No.
Well, I didn't take the 3 away this time. I just took the x squared. I was just taking the x squared. Okay, if you start to question if you took it out correctly, distribute back through and see. And if it distributes through and you end up with what you started with, then you did it right. Okay? Just make sure when you do it, you take the greatest common factor and not just a common factor. Okay? Does that make sense? So if I had 18 and I don't know, 36.
27.
Okay, so 18 would be the biggest. If I took 9 out, I wouldn't have taken the biggest one out. You see what I'm saying?
Yeah.
So just make sure you're looking for the biggest, greatest common factor whenever you do it. The greatest, not the common. Does that make sense? Okay.
Is it wrong? Is it wrong?
Well, the method that I'm going to show you, any other method that most teachers teach, it would be wrong if you didn't do it. The method I'm going to show you would let you do it at the end too, and it wouldn't be wrong. All right, so you have a sheet in front of you. It says factor by grouping. This is my favorite method to factor in because it just makes the most sense, and it follows foiling literally backwards, okay? All right, so we're going to work through that example that's up at the top that says factor 12x squared plus 14x, and I think the easiest way to do this is just to jump in and do it. All right, so step 1. And I'm not going to write these steps out since you have a paper printed in front of you with them listed. If you're one that just likes to listen and you don't like to write, then I have them printed out for you if you want to copy it into your notes, because I'm always that one that it helps me to write it. I remember it if I write it, but whatever you want to do. And we'll run through several more examples. All right. First step is to factor out the GCF if you have one. Do I have one?
Yeah.
Yes. What is the GCF? 2. And if you want to do it on your own, maybe fold your paper in half so you can see the steps and not the... All right, so when I take a 2 out, what's left?
6x squared plus 7x plus 2.
How do I know that I took it out correctly?
Plug it back in.
It distributes back through correctly, right? All right. Now, here we go. When we have a quadratic in standard form, and we've already talked about this, it's ax squared plus bx plus c, right? Looking at this, what is a?
6,
What is b?
7.
What is c? Okay? It will help you as you start if you write out your a, your b, and your c. If you don't need to, I understand, but it'll kind of help you get everything together. Here comes the fun part. This is the puzzle part, okay? Remember that distribute problem that we did? I don't know where my pen is. And we had 2 binomials, and then we ended up with 4 terms, and then we reduced it to 3 terms.
Yeah.
Remember, you know what I'm talking about? Before we combine like terms, we're going to get to that 4-term part right now, okay? We're going to rewrite this in 4 terms instead of 3. So here's what we're going to do. Take the A and the C and multiply them together,
Okay.
okay? Hardest part of factoring right here. Find 2 numbers that multiply to 12 but add to positive 7. 4 and 3. This is an easy one, remember, so y'all stay with me. But 4 and 3, right? Does everybody see why it's 4 and 3?
But it can be subtract too.
Yep. You'll have signs that are going to change. Huh? Yeah.
Okay.
I'm going to show you. I'll show you. All right.
Then it plug.
So remember when we were foiling and we foiled and we got 4 terms and then we combined like terms? Well, we're going backwards. So this has already got the like terms combined. We're going to split those like terms up, and this is telling me how to split them up.
So it's 4x.
So it's 6x squared plus 4x plus 3x. Do we agree that 4x plus 3x is still 7x? It's still the same value. It's the same thing. I've just split it. Well, we're not done yet. So remember I told you the key to factoring is being able to find a GCF. I want you to think about this. I want you to think about this as two separate problems. Now that 2 is just going to carry on down with us. Just ignore it, okay? Look at the first two terms there, 6x squared and 4x. Do they have a GCF?
Yeah.
What? 2x. If you take a 2x out of those first two, what's left? 3x. And 2, you took an x away from them, remember. Always keep your middle sign. It's always going to stay here.
But how'd you get plus? Oh, never mind. Wait, you have to keep plus 2?
They did it in different, I did it in a different order whenever I typed it up in that. But it doesn't matter. Your order does not matter. It doesn't matter if you do 4x plus 3x or 3x plus 4x. Because at the end, we're going to come back with the same answer.
So.
How about, yeah.
Wait, that's not what it's showing.
That's what I just said. It's because it's just in a different order. It's okay. You see, whenever I typed it, I did the 3x first. I did 3x plus 4x.
So
We'll come back to the same thing.
3x plus 2.
If you take a so look just at this. If this was a whole separate problem and I said, factor out the GCF from 6x squared plus 4x.
2x and
2x, and then what's left?
3x squared.
If you take a 2x out, so you divide it by 2x, it leaves me with 3x plus 2. What's the GCF here?
None. What? No, none.
1 is always a GCF. If you can't find anything else, 1 always works. So, of course, if I divide everything by 1, it stays the same.
Okay, so we're just splitting them up.
Yes.
Okay.
What do you notice? Because I got to have a GCF. And if you don't have one, hold the place with a 1. You got to take out a GCF. And if it doesn't have a GCF, you got to put a 1.
Thank you, Avery.
Just ignore that example right now. Yes. Yes. Yes.
So are we done?
Almost.
Okay.
Look at what I have. Look at what I have. What do you notice?
3x plus 2.
I have 3x plus 2 twice, right? All right, don't square it. And I want you to think about this. This is where you really have to wrap your brain around it. I'm going to factor out a 3x minus 2. I'm going to say now, if I look at this as a whole, that this is a GCF for these two terms. So this 2 is still here.
We're trying to get it to look like what we did last
Yes.
How is it the GCF of both of them and
Because do you agree that I'm multiplying right here? I'm multiplying by the same thing. If I'm multiplying by the same thing, I can take it out. So I'm going to take it out, and I'm going to take it out of both of them. What is left? 2x plus 1. See how on the example that's on your paper we came back to the same thing? It's just that I inverted the 4 and the 3.
But what do you? How did you make it only 9?
Okay, so think about it. Let me write this for you. If I had 2x times y plus 1 times y, and I told you to factor out the GCF, what would you do? Would it be 2y? The second one doesn't have a 2. It'd just be y. Well, but they're not like terms, so you can't combine them. Because this one's got an x on it. Right? So what I'm asking you for here is what's the GCF? Y, right? If I take that out, I don't write it twice, I just write it once, right? I take it out and I say 2x plus 1.
Okay, that makes sense.
My y is just 3x plus 2. I'm just taking a whole chunk out instead of just one value.
Will there be a section in the homework where it's just finding DCF?
Absolutely. All right, before we do another one, let me tell you this, because this book is set up a little bit different, so to make sure that you have plenty, the reason that we factor is we factor to find zeros. We factor to solve for x, okay? So when we do this, and let me take this same equation. Actually, I didn't need to go back. And we've already factored it, but let's say in the beginning, it said this. Was it plus 14x plus 4 equals 0. Okay. And I needed to solve for 0. And we've already talked about how to solve this graphically. What would you do?
I would plug it in.
On the calculator.
I've already figured.
And find the zeros, right? But this is how we're going to work through solving it algebraically, one of the methods anyway. Once we factored this, okay, notice that it has the equation must equal 0, just like when we were graphing, okay? Once we factored this down, we had 2 times 3x plus 2 times 2x plus 1 equals 0, right? That's what it looked like when we factored it. Tell me this. This is the part that just really makes sense to me. I hope it does to y'all too. If you have 2 things that multiply together to give you 0, what equals 0? One or both has to equal 0. Do you agree? There is no other way to get 0 when you multiply things together unless at least one of them is 0. In other words, if this equals 0 and or that equals 0, it would make the equation true, right? So all you have to do is take each piece here, set it to 0, and solve them separately. Why am I getting 2 answers? Think about the graph. There's 2 solutions. It's crossing, that parabola is crossing in 2 places, right?
What about the 2 though? What am I doing?
Well, is 2 ever going to be 0? No. So you could think about it like dividing both sides by 2. It's not going to impact your answer. Any GCF, as long as there's no variable in it, is not going to impact your answer.
What if I had a variable in it?
If it had I'll show you.
So why do we get the slope?
Why what?
That's the last problem we get to work on.
If, just to answer your question, Dylan, if you had an variable in front, like let's say this was 2x times x plus 3 equals 0. Well, now 2x could be 0 and x plus 3 could be 0. So when I solve it...
So, wait, so if that one had a variable, that means we have 3
Yes,
zeros?
yes, yes. You won't, these are all quadratics though. You won't have any more than 2 zeros on any of these.
So 1 is on the
You have to set both multiplied parentheses equal to 0. Yeah, I got you. All right, flip your paper over. Just go through here and put an equal 0 on all these, because we're going to factor and solve and not just factor and solve. There's some tips at the bottom. Those will make a little more sense to you as we get a little bit further. All right, factoring when there is no leading coefficient out front is by far always the easiest. And the more you do, you'll see why. All right, what is A?
X.
No, what is A? 1. What is B?
6.
What is C? All right, it equals 0, so I'm good to go. What is A times C?
5.
Give me 2 things that multiply to 5 but add to 6.
1 and 5.
1 and 5. Does it matter the order that I put those in? Absolutely not. Okay, you're going to come back to the same thing. You can see we worked the first one differently than the example that's on your sheet, and that's okay. All right, rewrite 6x using these 2.
We can try plus x.
Yeah. I'm just trying to go real slow. Cut it in half. And factor individually. Now, why do I not have a number out front this time? We didn't have a GCF of the whole thing to start with in the beginning. I failed to say that, I'm sorry. But yeah, x squared, 6x, and 5 does not have a GCF, so skip that step, right? That first step says if applicable, which means if it's there, you do it. If it's not, go on to step 2, okay? What's the GCF of the first two terms here? Okay, if I take that out, what's left?
X plus 5.
Keep that middle sign. What is the GCF of these two? 1. What's left? If you don't get this thing the same here, you've done something wrong. Because every single time, if you pick the right two numbers here, this will happen every
So if you
time.
would have done it, x squared plus 1x and then 5x plus 5, you would have said
Yes, yes.
So how do we write it like?
you playing.
That's wrong.
That's the fake,
That's the fake
it's
bill.
only 11:15.
Okay. All right, so x plus 5. It's really funny the difference in the classes that I have, because if this had been my freshman class first thing in the morning, nope, that was the bell, And you're like, no, we got 15 more minutes. Finish showing me how to do this. All right, x plus 5, right? And what's left is x plus 1.
How did you get X plus 1?
Look at what's left if you cross those out. Okay, so look, because that's the whole goal, is that you multiply. If you FOIL this back out, you'll end up back here. Let me just show you in case you don't believe me. X squared plus x plus 5x. Do you see
Good morning,
this?
Canaan High School. Everybody should be in class. Please disregard the previous bell. We are on the delayed start schedule.
Then
At this time, we ask you to stand for the pledge of. And now,
all right, I'm just going to
another
keep working
Black
this
History
over.
moment with Miss Chicory.
Good morning,
Let's
Canaan High
focus
School.
on this instead of the
The
solving.
Friendship
Let's stop
Nine,
here,
or
so I
Rock
want to
Hill
get through one more
Nine, was a
example.
group of African-American men who went to jail after staging a sit-in protest at a segregated
Number 4 on
McCrory's
your
lunch
sheet.
counter in Rock Hill,
Yes.
South Carolina in 1961. The students were refused service in order to leave. When they did not leave, they were arrested. 9 out of the group were convicted and chose to take the sentence of 30 days hard labor at York County Prison Farm. The group gained national attention because they followed the 1960 Nashville sit-in strategy of jail, no bail, which lessened the financial burden civil rights groups were facing. These sit-ins began to spread across the South, ultimately changing the face of American business by granting equal service to African Americans. The Friendship 9 convictions were overturned in 2015 by the nephew of the judge who sentenced them. And prior to that, in 2007, the city of Rock Hill unveiled an historic marker honoring these brave men. The Friendship 9 message is, never forget where we all came from, and don't be afraid to press on toward a better future by doing what is right. Thank you.
Okay.
Thank you, Miss
A
Chicory.
times C is 6.
Okay, some announcements you need to
Negative
hear.
1 times negative 6.
Attention students who received
Positive 6.
invitations to today's Young
Plus
Adult
negative
Book
6.
Award voting dessert party. Don't forget to come to the library
That's not my
today
A anymore.
during
I took it
lunch
out.
to vote on your favorite Young Adult Book Award nominee and enjoy some delicious dessert. That is today.
So where do I go?
Any student who received an invitation to today's Young Adult Book Awards voting dessert party. All right, the results of the Penny Wars from Monday and Tuesday are in. In first place
Here's where
are the
this one's a
juniors
little
with
bit different.
$1.49. In close second place are the freshmen with $1.47.
They cheated.
The sophomores are in a big third place with 17 cents, and in last place are the seniors with 7 cents. All right, guys, we got to get some pennies out of here.
Middle
Let's get
sign
going.
has
Please
to stay.
continue to bring in your change and cash. This is a United Way fundraiser. Don't forget.
GCF?
Pop Papa John's Pizza will be sold this
Now
Friday
look what I
during
did.
lunch.
I'm
Don't forget
taking
there
out
to
a
bring your
negative
$2.
6.
Again, a reminder, this
Right?
week
'Cause
is
that
the
middle
Future
sign had a
Farmers of
mistake.
America Week, known
So what's
also
left?
as FFA Week. Each day, we will have spirit
If
days
this
to
is
raise
ever
awareness of the
negative,
importance of our farming
This
industry.
sign is gonna change.
Thursday
when
is
you
where your
factor.
favorite brand,
Every
and
time.
Friday is where you're blue and gold. Thank you for participating in FFA Week.
X
It
minus
means a
1.
lot to the organization. Also, a couple other quick reminders. If you're going to go to Central Carolina, do dual enrollment, you got to take the placement test. Don't forget to come to guidance and sign up for that.
And then we just said.
Any junior girl, again, it's
If
almost
you're solving,
time
I'm not gonna give you solve
the
tonight.
deadline
Tonight I'm just
for
gonna
signing
give
up
you
for
fact.
Girls State
We
is
just didn't have time to
Friday.
focus
See,
enough
this
on
too,
this.
if
That's
you're
the
gonna
answer.
go to the
That's what
Girls
I'm trying to
State
get
being
to.
held June
This recorded. If something is missing, if a B is missing, which is probably gonna be the most
It's gonna
likely,
be
or C,
0?
it's 0, okay? If C is missing, then you'll factor out an X from it. You'll see what I'm talking about whenever you get to that. But specifically, if B is missing,